Hi guys, this is another video on implicit differentiation. I'm going to cover up the basic concept and there will be two problems for practice in this block. Okay, so what we have is if I wanted to kind of differentiate an implicit function, what exactly is an implicit function? So first of all, if you know that, sometimes you have functions like this, y equals to f of x. These are explicit functions like y equals to x squared plus 4x plus 3. Here you have y one side and x one side, and x is this, y is the subject in terms of x. What I do is when you get something like this, when you're getting something like x squared plus y squared equals to radius squared, which is like equation of circle. What do we do in these kind of questions when you have to differentiate? Or maybe x cube y cube equals to sine x. How do you find out an expression for derivative? Because to convert into explicit function, it takes quite a lot of effort and it becomes complicated. So what I'm gonna do is I'm gonna help you with simple understanding of the implicit. So let us say if I'm starting with the first one. Okay, so the first one is if I want to differentiate, your derivative for first one is going to be 2x plus 4. That's your derivative of 2x plus, because x squared is going to be 2x and derivative of 4x is going to be 4. Now, if I wanted to differentiate x cube y cube equals to sine x, it's a little complicated. So what I do is first I explain you simple differentiation of y with respect to x. So first of all, if you have, let's say, y cube differentiation with respect to x, suppose if you want to differentiate y cube with respect to x, so this is a little awkward because here you're differentiating with respect to x, here you're differentiating y cube with respect to x, so it's a little challenge, and that's the whole trick all about. So when you take a derivative of y cube is going to be 3y squared, as if normal derivative of x squared, how do you do? X cube. But because you're differentiating here y and x, you can't completely express this as a derivative of purely kind of in terms of y. So you have to attach, only one thing you have to remember is whatever variable you're differentiating with respect to x, you have to just write down dy by dx. Then if it's not clear, look at the next one. So suppose if I want to differentiate d by dx with respect of x to the power 10, y to the power 10. So it's gonna be y to the power 10 is gonna be 10 y to the power 9 as if normal x differentiation into dy by dx. Next one is if you want to kind of differentiate, let's say if you have y equals to or let's say if you have z, let's say you want to differentiate z cube with respect to x. So if I want to differentiate z cube with respect to x, it's going to be 3z squared into dz by dx. So only thing that you remember is just multiply the derivative which you're completing. So z cube derivative is 3z squared normal into dz by dx. So if you want to try this one on your own. So you can pause the video and try this one after this example. So if you want to differentiate, let's say x cube plus y cube equals to 3xy. If I want to differentiate this one, it's a little tricky. So now this is my whole procedure begins for implicit. So if I want to differentiate x cube plus y cube equals to 3xy, what do we do? Do we make y the subject? It's gonna be really tricky. So what we do is we simply differentiate, and you have to find out expression for dy by dx. That's the most important because you want to find out expression. So what you do is you want to differentiate d by dx, with respect to x. So derivative of x cube with respect to x is going to be 3x squared, but derivative of y cube is going to be 3y squared, and it's plus, so I'm going to put plus, into dy by dx, because you can see out here what the example that I gave equals to. Now I have to differentiate other side as well here, so you have to apply product rule. As normally students just consider that okay, derivative is going to be y, 3y, so they go wrong. So when you apply product rule on 3xy, so 3 times I do is x times derivative of y. So x times, if I differentiate y with respect to x, you'd get dy by dx. plus, if I differentiate x with respect to x, so I'm going to get 3y. So this is the main step. X into derivative of y. And derivative of y is going to be dy by dx. It's with respect to other variable. And you have 3y because 3y and derivative of x is 1. So that's why it is 1 out here. So now what's the next step? What I do is I collect the like terms, like dy by dx terms one side. So you first simplify. 3x squared plus 3y squared dy by dx equals to 3x dy by dx plus 9y. So that's your derivative relation. Now what I do is make dy by dx the subject. So when you make dy by dx the subject, so you get 3y squared minus 3x equals to 9y minus 3x squared. So dy by dx is gonna be 9y minus 3x squared over 3y squared minus 3x. So I repeat again, derivative of x cube is gonna be 3x squared, derivative of y cube is gonna be 3y squared dy by dx, derivative of 3xy is gonna be 3 times x dy by dx, because you can't differentiate, like here you are applying product rule, and plus 3 times y. And then you collect dy by dx terms together, other side you divide, but after taking dy by dx common, you're going to get this expression. So this is your answer. Now let's try one more example for this. So let's say I'm trying to differentiate cos of x squared y cube equals to x squared plus y squared. I want to differentiate this. It's interesting. So first of all, I have to be really alert about, I need to know chain rule pretty well for this example. So you differentiate both the sides, you attach d by dx, I want to do d by dx. So what you're going to get is derivative of cos fx. If you notice, the derivative of cos fx is going to be, negative sine fx into f dash x. So it's going to be negative cos x squared y cube into derivative of x squared y cube, where you have to apply product rule. So it's going to be x squared as it is into derivative of y cube, which is 3y squared dy by dx, 3y squared dy by dx plus y cube as it is into derivative of x squared, which is 2x. So we have got here left hand side, and right hand side is going to be 2x plus 2y dy by dx. Alright, so just don't ignore the multiplication with dy by dx, otherwise it's going to go wrong. So then the next step is to make dy by dx the subject. So if you open up the bracket, so it's going to become negative 3x squared y squared cos x squared y cube dy by dx plus 2xy cube equals to 2x plus 2y dy by dx. Now if you take dy by dx common, if you collect everything one side, you're gonna get dy by dx equals to bring this thing this side, so it's gonna be 2x negative 2xy cube over, if you take common, so that's gonna be negative 3x squared y squared cos of x squared y cube and negative 2y, because if you take common and see that, that's what you're gonna get. Hope this video helped you understand implicit differentiation. In case if you want to try last example, here is the last example for you. So if I want to differentiate, let's say e to the power x squared y equals to sine xy. Let's do where you have two product rules. So that's gonna be interesting. So first of all, if you want to differentiate such examples, so you have to take the derivative both the sides. Alright, so e to the power x squared y is going to be, if you remember, e to the power fx derivative is going to be e to the power fx into f dash x. So that's what is the chain rule which you are going to apply out here. So e to the power x squared y into derivative of x squared y is going to be product rule. So x squared into derivative of y is going to be dy by dx plus y as it is into derivative of x squared, which is 2x. Now my right hand side is going to be Derivative of sine fx is, if you know that, it's going to be cos fx into f dash x. That's the derivative for sine rule, sine composite function. So what exactly do we do for sine xy? So it's going to be cos xy into derivative of xy, which is going to be x as it is, dy by dx plus y, because derivative of this, I'm applying product rule for xy differentiation. So that's your very important step. Now you open up the bracket, collect the dy by dx terms together. So if I do dy by dx, it's gonna be, if you were doing a single step, you can't do it clearly, so you have to kind of open up the bracket. So it's gonna be x square e to the power x square y plus 2xy equals to x cos xy dy by dx, I'm opening the other bracket, plus y cos xy. So now when you take dy by dx common, so dy by dx common, from both the side, collecting this thing this side and send this thing other side, so you're going to get y cos xy minus 2xy upon x square e to the power x square y minus x cos xy. This is the final derivative. So hope this video helped you. You can watch the further practice on implicit differentiation in the next video.